Hello, welcome to Flipped. So today we are on acids. Okay, we'll start off with the definition of acid and really how to differentiate strong and weak acids and their relative acidity. Okay, so acids are really just substance that gives hydrogen ions, okay, which is in this case, which is H plus, okay, when dissolved in water. Okay, they will not give H plus when dissolved in other solvents, for example, ethanol or benzene. So by now you should know that solvents are really just a pool of liquid, okay? So solvents are really just a pool of liquid for you to dissolve something in, okay? To throw something in basically. Okay, so when you put in hydrochloric acid, for example, in water, it will dissociate, okay? It will dissolve. But if you put in hydrochloric acid into ethanol or benzene, it will not, okay? Because it's not water. So in your syllabus, just know that your solvent has to be water for the HCl to actually do its job as an acid. Okay, so this is the definition of acid, okay? Just these two sentences will do. Basically, they are substance that gives H+. Okay, so let's move on to the difference between strong and weak acid. So strong acid is really, they dissociate completely in water to give ions. Okay, so there will be no HCl left at the end of this reaction. So imagine HCl, you have okay, so this is your beaker with HCl. Okay, if you zoom in into it, okay, this is a chemical bonding. Okay, you will see that this is H, this is Cl, am I right? Okay, this is a covalent bond. Okay, so they all start off with HCl. Okay, in the beginning, but towards the end, okay, the reaction will just break them apart. Okay, they will all now just become H plus and Cl minus. Okay, they are separated now. Okay, in some sense they are divorced. Okay, so you can just imagine that they are, so at the end of reaction, there's no HCl anymore. They are all individuals, H plus and Cl minus. Okay, and take a look at this arrow. This is very important. This is a unidirectional arrow, means it only goes this way, okay, to the right. Okay, compare with this, which we'll talk about right now. Okay, so now weak acids, really, they dissociate partially in water to give ions. Okay, and all components will be present at equilibrium. So what do I mean? So I start off with this. This is what is this? Ethanoic acid, am I right? Okay, ethanoic acid begins with so similar to this. Okay, if I have a bottle of ethanoic acid here, okay, here remember to add water for it to dissociate. Okay, so similarly, if I throw in water here into my ethanoic acid, okay, this is how it will look like. Okay, it will also has CH3COO minus H plus, correct? This is together, but they will break up into individually CH3COO minus and H plus. Okay, but it will not be completely just between these two. You not understand what I mean? There's still some percentage of this remaining. Okay, how many percentage? What's the percentage for this? You don't have to know. This is actually A-level syllabus, but you just have to know that some of this will still remain. So in some sense, you can just think of it as it did not dissolve completely. Okay, only if you were to give a number, maybe only 50% is this, maybe 25% is this, 25% is this. Okay, this is a good rough gauge of how much is present at the end, which is called the equilibrium. Okay, this is an equilibrium. That means they do not go fully in this direction, neither do they go fully in the other direction. Okay, they can travel to both areas. And so at the end of the reaction, all three components will be present. Okay, hopefully that's understandable. And the pH of them is pH 3 to 6. Okay, that means compared to strong acid, okay, and strong acid is that this is less acidic. Am I right? Okay, whereas the strong acid one obviously is more acidic because it's closer to 0. This is closer to 7. Okay, remember our pH scale. This is 7, this is 14, this is 0. Okay, this is acidic, this is basic. Okay, So strong acids are here. Okay, weak acids are here. Okay, so you can see that weak acids are less acidic than strong acids. Okay, some examples of them can be found below. You just have to memorize these three. Each one's three for each will do. Okay, HCl, nitric acid, sulfuric acid for strong acid, acetic acid, citric acid, butanoic acid for weak acid. Okay, that'll be more than enough. Okay, so the next video we'll be talking about their reactions and the properties of acids.